We will graph the constraints. We'll shade on one side of the line. Here's a silly question that I'll need to kind of throw out there. Can I send a negative number of cartons of food? No. Can I send a negative number of cartons of clothes? No. Because I cannot send a negative amount, all we need to worry about is the first quadrant, where X and Y are both positive. So that's kind of a nice thing about this section that wasn't like some of the other sections, is that we're just worried about the first quadrant. With that, I'm going to put my grid on my graph paper. And really, I don't need to do X and Y right in the middle, because I don't need the rest of that stuff. I just need, I'm not going to put it on the edge, although, hang on, I've had students do that and it looked pretty good. I will put it on the edge. That's not my first inclination, but I've learned from students in the class that that's actually not a bad idea. I'll extend that a little bit, and I'll write this one on the edge. So there's the X and Y axes. And I'll graph the constraint. And again, because we cannot do a negative amount, I'm only worried about the first quadrant. Before I start putting numbers on here, I probably need to look and see what the intercepts look like. So let's do that. I'm going to show my work here at the bottom. We're going to graph 40x plus 20y is less than or equal to 24,000. And we will graph 25x plus 5y is less than or equal to 9,000. For each of those graphs, we're going to do the line. The line first, 40x plus 20y equals 24,000. And I've been saying for a couple of weeks, find the intercepts, find the intercepts, find the intercepts. This is why, because on these problems, you have to have the intercepts. For the x-intercept, y equals 0. Now, I've been working the problems with you, saying plug 0 in for y, work it out. Here's another technique you can use. If y equals 0, you could cover up the 20y. 40x equals 24,000. So that's 40 times x. We'll end up with 40x equals 24,000. To solve for x, we'll divide 24,000 by 40. $24,000 divided by 40, 600. So the x-intercept on this line is 600 comma 0, because y was 0 for that. I'm going to put a line because we're starting over. Y-intercept, x equals 0. So what I'm writing in this little column has nothing to do with what I wrote here. But we'll take the two and combine them to get our straight line. If x is 0, I can cover up 40x, and I get 20y equals 24,000. 20y equals 24,000. Divide both sides by 20. So 24,000 divided by 20 I'll type that in my calculator, and I get 1200. So y equals 1200. 0, 1200. I want to find the intercepts on the other line before I start messing with the xy axis. Because look, I cannot do 1, 2, 3, 4, 5, 6 all the way to 600. It's not feasible. And the same for the y-axis. So let me see what the numbers are, and that'll help me out with marking it off. For the second line, we need to graph 25x plus 5y equals 9,000. For the x-intercept, we'll plug in y equals 0. You could show the formal calculation as I had been doing, or you can use the cover-up technique. Cover up 5y, and we have 25 times x equals 9,000. So 25x equals 9,000. Let's divide 9,000 by 25, and I get x is 360. X is 360 there. And then for the y-intercept, x equals 0. Let's cover up 25x. I get 5y equals 9,000. Divide both sides by 5. 9,000 divided by 5 is 1,800. So in my second line, for x-intercept, I have 360, 0, and the y-intercept is 0, 1,800. As I look at those numbers, I'm thinking the y-axis, I could maybe jump by 2s and say 100, 200, 300, 4, 5, 6. No, I don't think I'll make it to 1,800. I'm gonna count each mark as 100, so I can get up to 1,800 on the y-axis. So 100, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I'll just number it 1 for 100, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. That might not be the best marking, but just for thinking off the top of my head, that's what I came up with. As I look at the x-axis, I have 600 and I have 360. The x-axis, I think I'm going to use a different spacing, which you can do, because I only need to really go up to 600. Let's go with 4 little squares for every 100. So make the numbers work for what we're looking at. Now, if you did the single squares for 100, you could do that. Your graph is going to be really scrunched up there near the origin, but that would be all right. I'm ready to plot my points. The first line is 600, 0, and 1,200 on the y-axis, and then connect those dots with a straight line. The second line is 360 350, comma 0. So, well, 350 would be right there at the second square from 300. A little bit more. There's 360. And then 1800 on the y-axis. And sketch a line that connects those. Now, in the previous section, we did a lot of shading, dumped the paint. There's some good news here. There's only one place for you have to worry about dumping the paint. And that's hugging the origin. And what's below these lines if I had done those single squares on the x-axis, the shaded region would be really kind of scrunched up in there. But there's the region we're interested in. That is the feasible region. Every ordered pair in that region represents a combination XY pair. Remember, X is the number of cartons of food, Y is the number of cartons of clothing. Every pair in that region represents something we could ship on the airplane. I could send 50 cartons of clothes and 100 cartons of food. If I send that much, I'm not maximizing the airplane. I'm not sending the most that I could send on that plane. But every point represents something that could be done.